Okay, ready to dive into something truly revolutionary.
Let's do it.
We're talking about quantum dot lasers.
Oh, yeah, those things are incredible.
Imagine self-driving cars that can see perfectly, even in the dark,
Hmm.
or doctors being able to see inside the human body with incredible clarity.
Like, way better than X-rays.
Way better. Quantum dot lasers could make all that happen and a whole lot more.
Now, that's what I call a game changer.
It really is.
So where do we start with all this?
Well, let's start with the basics. We're talking about infrared light, the kind our eyes can't see.
Right, right.
Current infrared lasers are already used in a bunch of applications, but they've got some major limitations.
Like what?
They're really expensive and hard to manufacture.
Oh, okay. So it's like wanting the latest, greatest gadget, but it costs as much as a fancy sports car.
Exactly. Not exactly an everyday purchase.
So where do these quantum dots fit into all of this?
That's the key to this whole breakthrough.
Okay, I'm all ears.
Researchers at ICFO, the Institute of Photonic Sciences, have been working with lead sulfide quantum dots.
Lead sulfide quantum dots.
Yep, these are tiny semiconductor particles. Think of them like artificial atoms.
I see.
And what's really special about them is they can emit light.
Okay.
And we can actually tune them to emit different colors of light, including infrared.
Oh, so it's like having a universal remote for light, but in the infrared spectrum.
That's a great analogy. But
Thanks.
why is that such a big deal?
It's a big deal because it opens up a world of possibilities. Imagine one material that can be used to create lasers for a ton of different applications.
So flexibility is the name of the game.
Yeah, absolutely.
I see. So what else makes these quantum dots so special?
Well, because they're colloidal, meaning they're suspended in a liquid, they're much cheaper to produce than those traditional infrared lasers.
Ah, okay. So we're talking more affordable devices using this technology.
You got it. And it gets even better.
Yeah.
They're also compatible with our existing silicon chip manufacturing processes.
Wait a minute. Are you saying this tech could become as widespread as computer chips?
It's definitely a possibility. Picture this. Quantum dot lasers being mass-produced and integrated directly into all kinds of electronics.
Okay, now my mind is racing with possibilities. What kind of applications are we talking about here?
Well, for starters, imagine sensors that are so sensitive they can detect hazardous gas leaks before we can even smell them.
Whoa. Talk about a life-saving application.
Right. And then there's self-driving cars. Right now, they use LIDAR systems to see their surroundings.
LIDAR, like radar, but with lasers.
Exactly. It's like giving the car super-powered vision. But current LIDAR systems are bulky and super expensive.
So how would these quantum dot lasers change that?
Well, for one, they could be made much smaller.
Okay.
And since they're so much cheaper to produce, they could make LIDAR systems much more affordable.
So more affordable, more compact LIDAR, what's not to love?
And we're just scratching the surface here. Think about medical imaging. These lasers could allow us to see inside the body in ways we never could before. Imagine being able to detect tumors at a much earlier stage.
Oh, wow. Or visualizing blood flow in incredible detail.
Precisely.
That's mind-blowing. And are we talking earlier diagnoses and busy treatments?
Absolutely. The possibilities are endless.
Okay, my mind is officially blown. So anything else these lasers can do?
Oh, just revolutionize how we communicate and share information.
Okay, I gotta ask, how do these lasers impact the internet? Everyone wants faster internet.
Right. Fiber optic cables, which use light to transmit data, are the backbone of the internet.
I see.
And these quantum dot lasers have some serious advantages over traditional lasers.
Like what?
They're more energy efficient, and they can operate at a wider range of wavelengths.
So we're talking about wider data highways and smoother streaming,
Jeez,
faster downloads. I'm
Wow.
sold.
And lag-free gaming, don't forget about that.
Oh yeah, sign me up.
It's a game changer.
It really is. I think it's a good place to pause for a moment, though.
Yeah, for sure.
We've covered a lot of ground from the science behind these lasers to their mind-blowing potential applications.
It's incredible, really.
It is. But there's so much more to explore.
Can't wait. Back again for more on quantum dot lasers.
Last time, gas detection, self-driving cars, medical imaging, we talked about it all.
Some pretty mind-blowing stuff, right?
These tiny particles changing the world, it's incredible.
And we're just getting started. Today, I want to push things even further, see what else we can imagine.
Okay, I like where this is going. What other possibilities are out there?
Well, how about advanced manufacturing? Creating things with incredible precision and efficiency.
Wait, lasers building things? How does that work?
It's all about focus. These lasers can focus light with insane accuracy. Imagine creating intricate patterns on microchips, drawing circuits with light.
So we're talking microchips. What else?
Think bigger. The intricate parts of a jet engine or even a satellite. These lasers bring a whole new level of craftsmanship to the table.
Precision, I get it. But what about speed? Manufacturing lines need to be fast too, right?
You're right, and that's where these lasers shine. They can work super fast, speeding up production without sacrificing quality.
So precision and speed, a powerful combination. Okay, what other areas could benefit?
Let's shift gears a bit. Talk about the environment. Environmental monitoring, to be precise.
Monitoring, okay, like keeping tabs on pollution levels?
Exactly. Remember how sensitive these lasers are? They could detect pollutants in the air or water in tiny amounts, giving us super accurate data.
Real-time pollution tracking, that'd be huge for protecting our planet and understanding how these pollutants spread.
Exactly. This kind of data would be invaluable for scientists and policymakers. But it's not just about monitoring, it's about developing cleaner tech, too.
Okay, so how do lasers help with that?
Imagine analyzing emissions from factories, finding out exactly what's being released, and then using that information to make things cleaner.
So we're talking about sustainable industries, less pollution, a win for the whole planet.
It's about using tech to tackle big challenges. And it goes even further. Think about solar energy. These lasers could make solar panels way more efficient.
More efficient solar panels, that'd be huge. How's that possible?
It's all about understanding how sunlight interacts with different materials, and these lasers allow us to study that with incredible detail. We could be looking at solar panels capturing way more energy from the sun, a big step towards a clean energy future.
So big problems here on Earth, but what about space exploration? Could these lasers help us out there?
Absolutely. Remember, faster, more efficient communication. Imagine sending data to and from spacecraft way out in our solar system.
Whoa, that's next level. High-definition images from Saturn almost instantly.
It's a wild thought, right? And it's not just communication. These lasers could revolutionize spacecraft navigation, guiding them with incredible accuracy.
So space exploration, faster, more precise, the possibilities are endless. This all sounds amazing, but I gotta ask, where are we with all of this right now? Is this stuff actually happening, or is it all still in the lab?
That's a great question, and the truth is, it's a bit of both. The potential is huge, but this tech is still pretty young. We've come a long way, but there are still some hurdles to overcome.
Like what kinds of hurdles?
But one of the big ones is stability. Remember, we're dealing with tiny particles, quantum dots, and they could be a bit finicky. Things like temperature changes can mess with their performance.
So making them more robust, less sensitive to the environment, that's a challenge.
Exactly. And then there's the issue of scale. Right now, these lasers are mostly made in small batches in labs. Figuring out how to mass produce them, keep them affordable, that's a big step.
Okay, so taking it from the lab to the factory floor, that's a crucial step. What else are researchers working on?
Well, they're always searching for new materials, new designs, pushing the boundaries of what these lasers can do.
So constant innovation, refining the technology, it sounds like a pretty dynamic field.
It is. They're also exploring ways to combine these quantum dots with other materials, like traditional semiconductors.
So it's not just about quantum dots on their own, it's about combining them with other tech, making them even better.
Precisely, taking the best of different worlds, creating something truly remarkable. And that's what makes this field so exciting. The collaboration, the cross-pollination of ideas, it's all about bringing different minds together to solve big challenges.
It's like the saying, two heads are better than one, but on a much grander scale.
That's a great way to put it.
Well, I think that's a good point to wrap things up for this part of our deep dive. We've covered so much ground, lasers, building things, cleaning up the environment, exploring space. It's been a wild ride.
I know, right? It's amazing to think about where this tech might take us next.
Welcome back. It's time for the final part of our deep dive into quantum dot lasers.
I can't believe how much ground we've already covered.
I know, right? But as with any powerful technology, there are always deeper questions to explore, like the impact on society.
You're absolutely right. We need to think beyond the wow factor and consider the potential downsides, too.
Exactly, and one of the first things that comes to mind for me is privacy.
Privacy, yeah.
We've talked about these lasers enabling incredibly sensitive sensors.
Right.
What happens when those sensors are used to collect data about us? Is that something we should be worried about?
Imagine a world where sensors can detect tiny changes in your heartbeat or even track your eye movements.
Oh.
That data could be incredibly valuable for things like personalized medicine or even targeted advertising. But It also raises some serious concerns about who has access to that data and how it's being used.
Yeah, it's like that whole smartphone dilemma all over again. So much data being collected about us all the time.
Yeah.
So how do we find that balance, between pushing the boundaries of innovation while protecting our privacy?
It's a tough question for sure. We need to have open and honest conversations about it and establish clear guidelines for data collection and make sure people have control over their own information and understand how it's being used.
Transparency is key. Okay, so privacy is one concern, but what about the potential for these technologies to be used, I don't know, for surveillance or even in military applications?
That's another crucial consideration. We can't ignore the possibility that these lasers could be used to develop more sophisticated surveillance systems or even weapons. It's something we need to talk about.
Yeah, it's a reminder that any technology can be used for good or for bad, right?
Exactly.
So how do we prevent these advancements from being used in ways that could harm individuals or even entire societies? I mean, that's a pretty big question.
It is a big question. And it requires global cooperation. We need open dialogue and ethical frameworks to guide the development and use of these technologies.
So it's not just about the scientists and engineers, it's a much broader conversation, right?
Exactly. It involves governments, research institutions, the private sector. Everyone really needs to work together to prevent misuse.
It's about being proactive and putting safeguards in place. Okay, so we've talked about privacy and potential misuse, but let's shift gears a bit and talk about the social and economic implications.
Okay.
We've touched on job displacement before, but I think it's worth diving a bit deeper. If these lasers lead to greater automation, what happens to the people whose jobs are affected?
It's a valid concern. As these technologies become more sophisticated, there's a definite risk of job losses in certain sectors. We need to anticipate those changes and be prepared.
So it's not just about developing the tech, it's about thinking about the workforce.
Absolutely. We need to invest in education and retraining programs, make sure people have the skills they need for the jobs of the future.
And what about people who might not be able to transition to those new jobs?
That's where social safety nets come in. Things like a universal basic income to ensure that everyone has a basic level of economic security, even as the world changes rapidly around them.
It's about creating a safety net, making sure that everyone benefits from these advancements.
Exactly. We need to ensure that the benefits of this technology are shared widely and that we don't end up with even greater inequality.
That's a really important point. It's about making sure everyone has a chance to participate in this new future.
That's the goal. We need to address existing inequalities and make sure everyone has access to education and opportunities.
That's a tall order, but it's definitely a conversation we need to be having. The future isn't set in stone. It's something we actively shape through our choices.
You got it. By having these tough conversations and being proactive, we can use these incredible technologies to create a future that's not just advanced, but also just and sustainable.
That's a great point to end on.
It really is.
We've explored the science behind quantum dot lasers, their amazing potential, and the challenges we need to address.
From the tiniest particles to the biggest questions facing humanity.
It's been an incredible journey. Thank you for joining us on this deep dive into the world of quantum dot lasers. We hope it sparked your curiosity and maybe even inspired you to think about the role of technology in shaping our world.